This video will have the worked out solutions for the last page of the review packet, page number 4, number 14, solving quadratic equations. Alright, as I look through this, I'm going to zoom in just a little bit for you. I'll make sure we're focused. Wait for it. Alright, so looking here, I want to solve for x. Every time I solve an equation, I want to look and see what form does it look like. I see an x squared, so that's like vertex form, so I'm going to do inverse operations. So because it's multiplication, I'm going to do the inverse, which is division. 3 divided by 3 is 1. So I'm left with x squared equals 9. The inverse of squaring is square rooting. So I have x equals, remember, as soon as I take the square root, I need a plus or minus because there's a positive and negative root of 9, and that is 3. If you want to check your equation, you could always substitute these back in to make sure you get it equal on both sides. So if you wanted to check, you can check 3 times 3 squared. Does that equal 27? 3 squared is 9. 27 equals 27. And you could do the same thing with negative 3. 3 times negative 3 squared, does that equal 27? Well, that's positive 9 again. 27 equals 27. You're not going to see me do all that work every time, but if you wanted to, you can, and you can always use it on the calculator as well. Scooching over here to solve for p squared. I subtract 12 from both sides because, again, I'm going to do inverse operations because I see a p squared. It looks like vertex form. The inverse of squaring is square rooting, square root, p equals. Now, I don't need a plus or minus here because 0 is not positive or negative. The only number that multiplies by itself to be 0 is 0. So p equals 0 is my solution. Scooching over here, again, I see an x squared. So, inverse operations. I add 7 to both sides. That undoes the subtracting 7. I have 16 equals 2x squared. A lot of us want to take the square root now because we see the 16 is a perfect square, but don't do it. We haven't isolated what's being squared yet. I have to divide by 2 first because 2 divided by 2 is 1. It'll leave me with an x squared, and now I can take the square root of both sides. When I do that, the right-hand side becomes x. The left-hand side is plus or minus square root of 8. Now, whenever I take the square root of an irrational number, I'm sorry, not a square root of an irrational number, a square root of something that's not a perfect square, it will be an irrational number, but I got to see if I can simplify that. So when I do that, I'm going to do this over to the side. I can do a factor tree and say that's 4 times 2, which is 2 times 2. So 2 times 2 times 2, take the square root. That's a perfect square, so I can do 2 squared times 2. The square root of 2 squared times the square root of 2, well, that would be 2 root 2. Square root of 2 squared is 2. Or I think about 8, and I think, what is the largest perfect square that 8 is divisible by? Well, I know that I can do 1 times 8 is 8, 2 times 4 is 8, and that's about it. So when I look at the factors, well, there you go. There's a perfect square right there. So I can break that apart. I can say, well, instead of square root of 8, I'm going to say that's the square root of 4 times 2. Or break it apart, and you get square root of 4 is 2 times square root of 2. So our answer, simplified, would be plus or minus 2 root 2. And there you go. Moving on to the next one. Again, when I look at this, I see something being squared. So I recognize that that looks like vertex form. I'm going to do inverse operations. Right now, I'm squaring this whole quantity, so to undo that, I square root. The left-hand side becomes x minus 2. The right-hand side, because I took the square root of 25, there is a positive and negative root of 25, and that's 5. Because 5 squared is 25, and negative 5 squared is 25. And now, because these are both rational numbers, meaning there's no square root over here, I'm going to break this apart into 2 equations because I'm going to be able to simplify it. Or I'm going to be able to combine the 2 and the 5. So x minus 2 is either equal to 5 or negative 5. And now, I can solve, I get x equals 7 and x equals negative 3. Scooching over here, if I solve for g, against g squared, I'm just going to do inverse operations, divide by 121. I get g squared is equal to, well, if I put that in my calculator, I get a decimal. But I don't want to do a decimal. I'm going to leave it as a fraction, and we'll see why. Because now when I take the square root, I have g is equal to plus or minus. I can take the square root of the numerator and denominator separately. And the square root of 9 is 3. The square root of 121 is 11. So now g is equal to plus or minus 3 11ths. Scooching over here, when I solve this equation, again, I recognize I have an x squared. I just got to do inverse operations. The first inverse operation I'm going to do is I'm going to add 10 because we're subtracting 10. Those add to be 0, so I'm left with x squared divided by 2 is equal to 16. To solve for x now, I'm doing x divided by 2. The inverse would be to multiply by 2. Those divide to be 1. I'm left with x squared equals 32. And now I can do my inverse operation of square rooting, and I get x equals plus or minus square root of 32. I have to try and simplify this if I can. 32 is not a perfect square, so the solution won't be an integer, but I can either do my factor tree and do, well, that's, what is that, 8 times 4, 2 times 2, that's 4 times 2, 2 times 2. Oh my goodness, we have so many 2's. 1, 2, 3, 4, 5 2's. So when I pair those up, I can do 2 squared, that's 2 of them. There's another 2, and then we have 1 left over. So the square root of 2 squared is 2. Square root of 2 squared is 2. Square root of 2, that's irrational. I'm going to leave that there. So this simplifies to be 4 root 2. The other way I can simplify that square root of 32, I can think of all the things that multiply to be 32. Well, that's 1 times 32, 2 times 16, 4 times 8. Anything else? That's all I can think of off the top of my head. So when I look at these, I have 2 perfect squares, 4 and 16, that are factors of 32, but I want the biggest one. So 16, I can break that apart into 16 times 2. Square root of 16 is 4. Square root of 2, we have to leave that as square root of 2. So you could do it that way as well. All right, scooching on to G. Looking here, again, I see an a squared. That tells me I just need to do inverse operations. Add 3 to both sides. I have a squared is equal to a negative 1. When I take the square root, well, square root of negative 1, there is no number that when you multiply by itself is negative 1. In other words, I should say there's no real number. There is an imaginary number. So when we get to this, if in your calculator, if I tried to take the square root of negative 1, square root of negative 1, it's going to tell me non-real answer. So I can just say no real solution. I have to say no real solution because there are solutions, which this might sound crazy, but there are imaginary solutions. So in Algebra 2, you're going to end up saying that a would equal plus or minus the square root of negative 1, and you will learn that square root of negative 1 is I. We came up with this imaginary number I. All right, looking over here for H, I see something being squared, so I need to isolate what's being squared, do inverse operations, because that's multiplied by 2, I divide by 2. I have y plus 5 in parentheses squared equals, 160 divided by 2 would be 80, so that must be 81. Now I can take the square root of both sides. I'll be left with y plus 5 on the left-hand side. The square root of 81, I'm going to get plus or minus 9, because 9 squared is 81 and negative 9 squared is 81. And again, because that's a rational number, I'll be able to combine these. So I'm going to break this apart. And I can solve here. I get y is equal to 4 and y is equal to negative 14. All right, one more in this row. Looking over here. Again, I see an h squared. So I got to do inverse operations. I can't combine these guys because that 2 is attached to the h squared. So I'm going to subtract 60 because that's a positive 60. And I know that positive 60 and a negative 60 add to be 0. I'm left with negative 2h squared on the left-hand side, and then I have negative 98 over here. To solve for h, I need to divide by negative 2, divide by negative 2. I get h squared is now equal to 49, and the inverse of squaring is square rooting, so you're good to go here. Plus or minus 7. And finally, our last row, scooching down here. Oh, now this one looks different. We do not see something being squared here. We see the product of two factors. We see x times x. This looks more like intercept form. And to solve these equations, we're going to use the zero product property. So if I'm multiplying things together and they equal 0, I know one of them must be 0. Well, I can look at that 5. If I try and set 5 equals 0, heck no, that's not going to happen. But x minus 3 could be 0. X plus 2 could be 0. And we could get that if I add 3. If x is 3, then that would be 0. And 5 times 0 times anything will be 0. And if I solve here, I get x equals negative 2. And if I substitute negative 2 in, negative 2 plus 2 is 0. 0 times anything is 0. So we have two possibilities. All right, looking over here, I see the same thing. I see the product of two factors is 0. And if that's the case, then using the zero product property, one of them must be equal to 0. So when I solve this, I get 3x equals 7, or x equals 7/3. I'm going to leave that as an improper fraction. I could make that a mixed number. What would that be? 2 and 1/3. But I do not want approximate answers. I want exact answers. So here, add 1, I get x equals 1. So we have 2 solutions there. And our final problem, solving this, again, a product of 2 factors equals 0. That means this guy's got to be 0, or this guy's got to be 0. That's the only way it'll work. Well, x equals 0, I already solved for that. Now, subtract 10, I get x equals -10. There are my 2 solutions. All right? And that is the final problem for the review packet.